Yes, welcome to fact lecture. In the previous lecture, a basic symbol and classification of fact controller, it has been discussed. Now today we are going to discuss static synchronous compensator, that is a STATCOM. So static synchronous compensator, it is just defined as a static synchronous generator operate as a shunt connected static VAR compensator whose capacitive or inductive output current can be controlled independent of AC supply. So here it is very important, it is a shunt connected controller. So whatever the static synchronous compensators are there, all this its a category and sub classification, it is connected in shunt or parallel. And when the fact controller is connected in shunt or parallel, it is going to inject capacitive current or consume capacitive or consume inductive current. So either it may be connected at the center of the transmission line, sending end and receiving end. We will see what is the best location of STATCOM in the transmission system or in the power system. But here, one more important thing is that it is independent of say it is independent of supply voltage. Okay, it is independent of supply voltage. So basically there are two type of static synchronous compensator. One is called as a voltage, it is based on a voltage source converter or current source converter. So this is a voltage source converter. It is a voltage source, and this is current source converter. Okay, as it is connected in parallel or it is shunt, therefore it is a STATCOM, it is a shunt connected compensator. Now in case of voltage source connector, voltage source converter base, either it is a DC capacitor or this in, and thus thyristors are connected in parallel, whereas in case of series controller, inductor is connected, or this is the symbolic representation. In the power system, voltage source converters are basically, it is preferred because of its cost in the cost of its device, isn't it? So this is the static synchronous generator operate as a shunt connected synchronous VAR compensator whose capacitive or inductive output current can be controlled. Definitely, the current should be in quadrature, phase quadrature with the voltage, or either it is going to inject or either it is going to absorb the inductive current. Now, static VAR compensator, again it is connected in shunt. Therefore, it is defined or it is explained as it is a shunt connected static VAR generator or absorber whose output is adjusted to exchange the capacitive or inductive current so as to maintain control specific parameter of electrical power system. Typically, it is a bus voltage over there. Now, it is somewhat a general category of STATCOM, but here it is again the cost of static VAR compensator is smaller than STATCOM. Definitely in STATCOM there are two types. One is the voltage source converter, second is the current source converter. And static VAR compensator is a we can say that without gate turn off devices are there. So here we are using without gate turn off. It is only we are able to conduct the it is able to control the firing angle of SCR, and by proper choosing the firing angle or by varying that firing angle, it is possible to control the inductive current and capacitive current which is going to inject or absorb in the power system. So it is a shunt connected, basically it is all are shunt connected static VAR compensator. Just I repeat it, as a shunt connected static VAR generator or absorber, either it is going to generate the VAR, that is a reactive power, or either it is going to absorb. When it is a inductor, it is going to absorb. So here it is going to absorb the current. Whereas when it is a capacitor, it is going to deliver the reactive current. So either adjust to exchange the capacitive or inductive current so as to maintain the control specific parameter of the electrical power system. And the objective of fact controller, objective of fact flexible AC transmission system is to modify the electrical characteristic of the transmission line to increase the controllability and increase the power holding capacity of the existing transmission line. This is our main objective. Now these are the generally term of a thyristor control and thyristor switch. Either it is called as a thyristor control. This is thyristor control reactor and thyristor switch reactor. What is the difference? We see one by one. And or alternatively, it is a thyristor switch capacitor or combination of control and switch. Means either it is can be switched in steps, say 100 kVR, 200 kVR, 300 kVR. So there is a switching. So with the help of either it is a thyristor switched capacitor or thyristor controlled reactor. Okay. It includes the separate equipment for the leading war generator as well as the lagging war generator. Either it may be a combination of or it may be a separate. Either here see, this is the static war compensator. It is going to consume the reactive power, whereas it is delivering the reactive current. So under such condition, it is a separate one for the thyristor control reactor and thyristor control capacitor. Okay. And it is a without gate turn off capability is there, and it is somewhat similar to the STATCOM. Now, what is the difference in all these parameters? We see one by one. Say, for example, thyristor control reactor. Thyristor control reactor. This is one. Thyristor control reactor can be controlled smoothly. Means there is a change in reactor value is adjustable with the help of these two thyristor connected in parallel. So if you are conducting the current, if you are changing the firing angle of these two thyristors, say just I will draw one waveform. So by varying the firing angle, we are able to conduct this much current. So here, if you are going to change the firing angle, again the current in the reactor, it is going to change, isn't it? So therefore, it is called as a thyristor controlled reactor. Second is the thyristor switch reactor. If you are going to conduct a fixed value of firing angle, the fixed value of firing angle is there. So this become a thyristor switch. So it is a fixed angle alpha, that is the firing angle. So it become a thyristor switch reactor. So under thyristor switch reactor, the reactor is going to change in steps. Whereas thyristor controlled reactor, the thyristor value, it is going to change in a smooth manner. So there is a two difference value. It is a smooth manner as well as the switch manner. So see what is the thyristor controlled reactor, TCR, thyristor control reactor, a shunt connected thyristor control inductor whose effective reactance is varies in continuous manner by partial conduction control of thyristor walls, isn't it? So here we are going to change the firing angle, and by changing the firing angle, it is possible to control smooth control in the reactor value, isn't it? TCR is the subset of SVC, isn't it? There are different type of static war compensators are there. See in this, it is a static war compensator. There are different category. So it is one of the static war compensator, and current in the shunt reactor is controlled by a thyristor-based switch with firing angle control is possible. So by controlling the firing angle, it is possible to control continuous variation or reactor is varied in continuous manner, isn't it? Second, thyristor switch reactor. It is somewhat opposite in the sense here control is possible, smooth variation of reactor is possible. Here the reactor value is not possible, whereas we are going to control the reactor value in steps. Say for example, it is connected one reactor, second reactor, third reactor. Okay, and it is going to control with the help of switch. If this switch at position number 1, this reactor is come into the circuit. When the position number at 2, second reactor come into the value into the system, and when the selector switch is connected to that point number 3, this capacitor, the inductor, whose value say 100 MVA, 150, 200. So it is going to switch in the manner, and it is possible only because of the fixed value of firing angle. So by keeping the fixed value of firing angle, either it to the 0, so there is a full conduction, and when the firing angle is equal to 180 degree, it is act as a open switch. So a shunt connected thyristor switched inductor whose effective reactance varies in stepwise. So it is a change in stepwise manner by full or zero conduction operation of the thyristor value. Either you have to conduct the capacitor, your thyristor in the full manner. Say in this case, either it is a switched, it is going to zero value, here it is a zero value, or either it is a some steps. So if the firing angle is equal to 0, firing angle 0, it means that full conduction of AC current or AC waveform. So this is called as a zero angle and full conduction. And when the conduction is equal to 180 degree, it means that the switch is off. So therefore, the thyristor switch reactor, it is going to control either in steps value or totally switch on or totally switch off. So this is the two. Second is the thyristor switch reactor. Here thyristor control capacitor is not there, only thyristor switched capacitor, because the capacitor is controlled in step manner, not in the smooth manner. Means we can not going to, for the capacitor, it is going to control a smooth manner. Whereas here the number of capacitors are connected. Here the number of capacitors are connected, one capacitor, second capacitor, and third capacitor. Say for example, just for the, and again there is a switch, selector switch is there. When the at position number 1, first capacitor is going to circuit. At point number 2, the second capacitor comes into the circuit, and switch number 3. So here the capacitors are switched, or capacitors are controlled in step manner only. This is the difference between the thyristor controlled reactor and thyristor switched capacitor. So capacitors are switched in manner. So therefore, we does not find thyristor control capacitors. No doubt, with the help of combination of this one, it is going to control, which is going to obtain. We will see in the series type compensators. Okay. So presently, just for the basic point of view, you have to understand the difference between thyristor control reactor and thyristor switch capacitor. So see what is the thyristor switched capacitor. So thyristor switch capacitor, a shunt connected thyristor switched capacitor whose effective reactance is varied in step manner. So here the capacitor value, it is going to obtain in some step manner by full or zero conduction operation of the thyristor walls. So whatever the thyristor walls are there or SCRs are there, either it is going to conduct, full conduction is there, means the firing angle is equal to 0, and firing angle is equal to 180 degrees. See, the firing angle is equal to 0, so it is a full conduction, and when the firing angle is equal to 180 degree, it is a off position. So this is the difference in this that. So this is the some basic two type of thyristor. It is the static var compensator is used in the FACT device as a FACT devices. Okay. Now series connected controller. Similar to the shunt controller, there is a series controllers are there. So either we can use as a series compensation or we can go for the shunt compensation. So in case of series shunt compensation, we have seen the STATCOM. Now for the series compensation, it is a static synchronous series compensator, SSSC. So this is nothing but the SSC, static synchronous series compensator, similar to the STATCOM. The STATCOMs are connected in parallel and SSSC are connected in series of the transmission line. Again, similar to the STATCOM, there are two type of controller. It is a based on voltage source converter, and second is the current source converter. Here also there are two type. Either it is a voltage source converter and series source converter, and one more, when it is connected with the some storage system, either it may be a capacitor, it may be a superconductor device. This is used to improve the dynamic stability of the system, isn't it? Now, a static synchronous generator operated without an external electrical energy source as a series compensator whose output voltage is in quadrature with the transmission voltage and control independent of the line current, isn't it? So similar, the same definition is there. In case of STATCOM, it is going to control the current in quadrature, in phase quadrature, independent of the supply, independent of the system voltage, and here it is independent of the line current. So whatever the injection of voltage in series, it is independent of the line current. Okay, so static synchronous generator operated without an external electrical energy source as a series compensator whose output voltage is in quadrature with the current. Okay, with the current, then and then it is possible either to consume or say deliver reactive power, a reactive component, and hence control independent of the line current for the purpose of increasing or decreasing overall reactive voltage drop across the line. So this is the one important. It is used, why it is we are using it is increase or decrease overall reactive voltage drop across the line. We found that when the transmission line it is in the service position, it is going to drop some voltage, and to adjust that voltage, we can use the series compensator. Therefore, it inject the voltage in series with the in line with the system voltage. Okay, TCSC, the SSSC may include the transient rate energy storage or energy absorbing device to enhance the dynamic behavior of the system. So whenever there is a transient, whenever there is a disturbance in the transmission line, this disturbance may be due to sudden increase and decrease of generation, or there may be application of fault on the transmission line. There is a transient, and after transient, there is a some brief period. The system is going to settle to the new equilibrium position, and during that brief period, there is a more oscillation. To avoid this oscillation, we can use some storage system in conjunction with the voltage source converter or series source converter, isn't it? So we found that if the oscillations are more, the power system require more time to settle its equilibrium position. And interconnected system behavior, it is found that there are real time, that is a brief, that is the dynamic stability period time, it is has been increased. To decrease the dynamic period, this system can be used. हाँ सर, हाँ सर, एक आप 12 बजे पहुंचिए ना, मैं भी निकलता हूँ 10 मिनट में। मैं आपको वो क्या नाम है, तो पेट्रोल पंप के पास मिल रहा हूँ। रिलायंस के आगे वाला पेट्रोल पंप जहां से मुड़ना है आपको, वो भी रिलायंस की पोजीशन में है। हाँ, okay, so under such condition the SSC may is used for the system. Okay, now again there are different types similar to the thyristor control series compensator and all these things. A capacitive reactance compensator which consists of a series capacitor bank shunted by the thyristor controlled reactor in order to provide the smooth variable series capacitive reactance. So it is just similar to the static war compensator. Here it is possible to control the capacitive power or capacitive reactance in series with the transmission line. This is the line, and it is possible to control the say this is the inductors. It is connected in parallel with the capacitor. Here, if the conduction is changed, say for example, alpha is equal to 0, that is the conduction angle is equal to 0, entire current is going to flow from the capacitor. So here the full capacitor value is going to utilize it offer its basic or base impedance, whereas some alpha is equal to say 20 degree. So under such condition, the conduction of current is going the conduction of current is there, and the current is going to flow from the inductor and less current is going to flow from the capacitor. So in this way the capacitor value can be changed, or the capacitive reactor can be changed for the transmission line which is connected in series with the transmission line with the help of conduction of thyristor. So this much part is thyristor controlled reactor, and this is only the capacitor. So with the help of thyristor controlled reactor in conjunction with the capacitor, it is possible to obtain the smooth variation of capacitor. So this is the meaning of thyristor control series capacitor. Earlier we have discussed that capacitor cannot be controlled in smooth manner. It is going to control in step manners. Here, in conjunction with the thyristor controlled reactor, it is possible to control the capacitor value. Therefore, it is called as a thyristor control series capacitor. A capacitive reactance compensator which consists of series of capacitor bank shunted by, this is the shunted by thyristor controlled reactor in order to provide a smooth variable series capacitive reactors. So for today's lecture, we will stop here, and next time we will continue this topic.